You're staring at a massive, messy trail of dots on a paper strip, and the exam paper tells you to mathematically prove acceleration for full marks. Instant panic, right? Well, stick with me through this explainer. We're skipping the fluff and going straight into the core strategy and examiner logic you need to completely hack the Cambridge IGCSE Physics 0625 exam. Let's master the motion and ticker tape timer practical right now. So here is that scary past paper style scenario. You're handed a chart made entirely of paper strips of varying lengths. The command? Mathematically prove acceleration. Your brain probably freezes, and your grade boundaries are suddenly at massive risk. But honestly, take a breath. Once you decode the underlying data here, it's a total breathe. I'm going to show you exactly how. But first, we need to talk about why ordinary revision fails. The most painful mistake I see learners make isn't actually failing to understand the physics. It's failing the exam language. You're bleeding precious marks on vague explanations. You're forgetting a tiny critical unit. Maybe you're rounding your numbers way too early in the calculation, or you're jumping to huge conclusions about the trolley speed that aren't even supported by the data. Listen, ordinary revision just focuses on memorizing facts. Exam mastery, that's about exactly how you communicate those facts to the examiner. Okay, let's get you your first quick win. It is literally the single most important number for this entire practical, 1/50. The ticker tape timer produces a dot, or a tick, every 1/50th of a second. It's a slightly old-school piece of tech for sure, but it is incredibly precise. You need to remember that every single gap between two consecutive dots represents the exact distance the trolley moved in exactly 1/50th of a second. Burn that number into your brain. It's our absolute mathematical foundation. So, how do we actually gather this data? And how do we do it safely, making sure to catch the trolley so it doesn't fly off the runway and crush your toes? You just follow these exact, syllabus-approved practical steps. First, pull a 1-meter length of tape through the timer. Next, you're going to cut that tape on every 11th dot. Why the 11th? Well, that gives you exactly 10 spaces, which represents 10 ticks. Finally, take those successive strips and arrange them side by side to make a chart. Simple, right? Now, to translate those physical paper strips into hard exam-winning data, you've got two primary tools. Your equations. Average speed is the total distance traveled divided by the total time taken. And acceleration, that's your change in velocity divided by the time taken for that change. Since every single strip of tape represents the exact same amount of time, remember those 10 ticks, the physical height of the strip directly correlates to the distance traveled in that specific time interval. It's literally a physical graph. Now, I need you to stay highly focused here. In just a moment, I'm going to show you the exact examiner clue that flips this entire question and elevates your answer straight into the top band. Leaving now means missing the one specific word the examiner is desperately hunting for. But honestly, it won't make any sense without understanding the framework first. So let's build that framework. To stop losing marks to careless errors, you need to apply this exact 4-step framework to every single data analysis question you face. It's an absolute game changer. Step 1. Identify the core physics concept. Step 2. Pull your specific evidence or data straight from the chart. Step 3. Apply scientific reasoning to connect that data back to the concept. And Step 4. Wrap the whole thing up in precise examiner wording. Concept, evidence, reasoning, wording. Let's see this framework in action because it really does change everything. Take a look at this flawed student answer. The dots get further apart so the trolley goes faster. I mean, yes, it's physically true, but it scores incredibly poorly because it's just so vague. Now look at the improved top band answer. The distance traveled in the 10-tick time interval increases, proving an increase in velocity over time, which is acceleration. Do you see the difference? The top band answer uses our framework to explicitly link the specific data, that 10-tick interval, straight to the scientific reasoning. That is exactly how you secure full marks. Okay, let's escalate the stakes a bit with a challenge. Take a really close look at this statement. The tape chart shows constant speed because the tape strips are placed side by side on a horizontal line. Based on the experimental method we just covered, can you spot the critical error in this student's reasoning? Think about it for a second. Seriously, pause this explainer right now, grab a piece of paper, and write down your corrected answer to that flawed statement using our 4-step framework. Remember, concept, evidence, reasoning, and wording. Let's see if you can truly think like a Cambridge examiner. Go ahead, I'll wait. All right, here's the crucial reveal. Did you catch it? The student completely confused the setup of the experiment with the actual results. The horizontal baselines, that's just how you physically arrange the chart.
The examiner style correction reveals that you must state the lengths of the tape strips are identical to prove the velocity isn't changing. Remember, the height of the strip is the distance traveled over time. If all those 10-tick tape lengths are the exact same height, the distance is the same, meaning the speed is constant.
Now, before you ever turn the page and move on to the next question, you have got to run through this final mental checklist. Don't throw away easy method marks. Ask yourself, are your units correct? Did you use the right variables on your axes? Is your safety guidance included? And is your graph scale actually accurate? Doing these quick checks is exactly what separates the good students from the absolute great ones. So you've now got an incredibly powerful framework to answer basic motion questions and construct your charts. But here is the huge unresolved problem. What happens when your data doesn't behave perfectly? What happens when you've got massive glaring anomalies in your ticker tape chart? Well, this final missing piece, knowing exactly how to evaluate unreliable data, is what truly unlocks the top band. And you can only find that solution in the next explainer. To get your hands on that top band evaluation framework and secure your full marks, you need to head over there right now. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Seriously, jump straight into the next explainer to unlock that final missing piece. Are you ready to evaluate flawed data like an absolute pro? I'll see you over there.